Transamination. It is a process by which an amine group is removed from an amino acid and it is transferred to an acceptor keto acid, which generates an amino acid version of the keto acid and the keto acid version of the original amino acid. So in this case we have labeled it as 1 and 2. Amino acid 1 is now converted into a keto acid 2, whereas a keto acid 1 is converted into an amino acid 2. Almost all the amino acids participate in transamination reactions, but there are some exceptions. Lysine, threonine, proline and hydroxyproline do not participate in transamination reactions, whereas the other amino acids do participate. Let me take one example. Glutamic acid and oxaloacetic acid are reacting, where glutamic acid is considered as a donor, whereas oxaloacetic acid can be considered as a acceptor. This is acting as a keto acid. This glutamic acid is now converting into an alpha ketoglutaric acid, which is the keto acid version of this amino acid, whereas the oxaloacetic acid is getting converted into aspartic acid. The steps involved could be discussed under two different headings. In one way, we can say that the three steps involved are transamination, followed by tautomerization and hydrolysis, or for convenience we are putting it into 4 different steps. The first step being the Schiff base formation, followed by the removal of H+, addition of H+, and finally the step of hydrolysis is involved. Let us see in detail. There are 2 steps. For this step 1, the mechanism has been given. Amino acid 1 is being reacting in the presence of pyridoxal, and this amino acid 1 is converting into a keto acid 2. The pyridoxal is converted into pyridoxamine. PM refers to pyridoxamine. Whatever pyridoxamine that is produced in step 1 will participate in step 2. There the pyridoxamine converts back into pyridoxal. So if at all we look at the mechanism, in the first step the pyridoxal will interact with the amino acid 1, where a water molecule is being removed and an aldimine is formed. Aldimine, or we discussed it as the Schiff base formation. Once the Schiff base is formed, there is an activation of the hydrogen, and this hydrogen is taken into the system. So this involves a loss of proton, and once the H+ is lost, there is a delocalization of the electrons, which lead to the formation of a inimine. This is a quinonoid form. It is also resonance stabilized. Now in this form, when there is an addition of a proton, slowly this inimine form is converted into a ketimine form. Within this ketimine form, in the presence of water molecule, we say hydrolysis occur, and once hydrolysis occur, this is generating pyridoxamine. Methionine is coming out along with a keto acid. So this amino acid is converting into a keto acid. What is the role of methionine here? We can see once a methionine is involved, it is acting as a cation. It is withdrawing the electron density from the system, thereby it is enhancing the rates of the reaction. Also it is creating a planarity within the molecule. Devoid of this ring is not expected. So in the presence of a metal, there is a 5-membered ring and also a 6-membered ring that is being formed, and this enhances the rates of the reaction. So in step 1, an amino acid 1 is converted into a keto acid 2. Step 2, it is also similar. In this case, now a keto acid 1 is being involved. Whatever pyridoxal that was involving in step 1, it converted into pyridoxamine. Now that pyridoxamine reacts with the keto acid 1, and this keto acid 1 will be converted into an amino acid 2, where the pyridoxal is regenerated. The steps involved are similar. In the first case, an aldimine is formed, then it is converted into inimine, which is a quinonoid form, then it is converted into a ketimine, and it just continue. So the steps involved, they are just similar. As I said, it is the Schiff base formation, then removal of a H+, addition of a H plus and hydrolysis. Well, once the amino acid 2 is generated, we say that the process of transamination is complete. So these are the steps that are involved in the transamination.